Hello, Assalamu alaikum. I am MD Shafayat Hossain Rizwan. The project name is Irregular Sequence Counter, and this is our group member. We talk about counter. Counter is the widest application of flip-flop. It is a group of flip-flop with a clock signal applied. Counter are two types: asynchronous and synchronous. Counter can count specific event happening in the circuits. Now we talk about irregular sequence counter. Irregular counter is a synchronous counter by which various random sequences can be sequenced. Now we can see application. First used in digital clock, for second for specific alarm timer, in frequency counter to control traffic indicators in any timer machine or methods displaying anything in design sequence. Now next slide about design pattern. Sequence is 73104. As we know, all those decimal number has 3-bit binary sequence. So it is a 3-bit counter that use 3 JK flip-flop. Now next slide, JK flip-flop characteristic table. Let's see for the first case when Qn 0 and Qn plus 1 is 1. And we can see Jk value 1 and don't care. When Qn and Qn plus 1 both are 0, it's represent Jk value 0 and don't care. For the third case, Jk value don't care and 1, and last case it represent again don't care and k value 0. Now next slide discuss next member. Thank you, sir.
Assalamualaikum. My name is Sheikh Jubaration from CS department. I am going to discuss about design pattern. Step 1: convert the sequence into binary. Sequence is 73104. As we know, all those decimal number has 3-bit binary sequence. So it is a 3-bit counter that use 3 JK flip-flop. And step 2: counter table of JK flip-flop. JK flip-flop characteristics table and present state and next state. Thank you.
Hello everyone, I am Rinmay. So I will now explain in the transition table. Our present state is 73104. So our next state will be 31047. So we have write down the values for in binary for both present and next state. Now we will find out the values of ff0, ff1 and ff2 using the JK characteristics table. So first we'll see the values for Q2 and Q2 plus. So if the value is 1 and 0, J2 and K2 will be don't care 1 for 0 and 0, and J2 K2 will be 0 and don't care for 0 and 0, J2 K2 will be 0 and don't care for 0 and 1, J2 K2 will be 1 and don't care for 1 and 1, J2 K2 will be don't care and 0. Now we will see for Q1 and Q1 plus. For 1 and 1, J1 and K1 will be don't care and 0. For 1 and 0, J1 K1 will be don't care 1. For 0 and 0, J1 K1 will be 0 don't care. For 0 and 0, the J1 K1 will be same. For 0 and 1, J1 and K1 will be 1 and don't care. Now we'll see for Q0 and Q0 plus. So for 1 and 1, J0 and K0 will be don't care and 0 for 1 and 1. Cannot cannot will be don't care 0 for 1 and 0. Cannot will be don't care and 1 for 0 and 0. Don't care will cannot and cannot will be 0 and don't care for 0 and 1. Cannot will be 1 and don't care. Now we'll find out the Boolean expression using the KMF for J naught, K naught, and same for J1 and K1. Now my favorite member Shanta Bashak will present the next part. Thank you everyone.
Hello everyone, my name is Shantakumar Vasak, ID 204294551. Today our presentation topic is irregular sequence counter, and I will start from here. Design pattern came in KMF J2 K2. When J2 0 0 0, then the result is don't care. When K2 when 0 0, the result is don't care. When J2 1 1 1 1, the result is don't care. When K2 1 1 1, the result is 1. This is our circuit simulation. In our circuit simulation, first of all, we get function generator and 3 JK flip-flop. All of clock pulse connected with positive signal and negative signal connected with the ground. Here J naught is come from K2 and K naught is come from Q1 bar. Here Q naught connected with DCD hex blue counter and J1 is come from Q2 and K1 is come from Q2 bar. When we connected Q2 to the DCD hex blue counter, then J is J2 connected with Q naught bar and K2 connected with Q bar. Q2 bar connected with DCD hex blue counter. When the function pulse high, we get output from DCD hex blue. The first output of DCD hex blue is 7 and the second output is DCD hex blue is 3. At the end of me, my group member Mirazul Rahman continue next. Thank you everyone.
Assalamu alaikum. My name is Mirazul Rahman and my ID is 2043497. My presentation is start from this slide. As our present state was 3 and we get next state is 1 as our expected result. Here we took 3 JK flip-flop and a function generator for power, and all clock are connected with positive of function generator, means all clocks are connected with high. Here J naught is connected with Q2 and K naught is connected with Q1 bar, and we get output from Q naught and it is connected with counter. After that J1 is connected with Q2 and K1 is connected with Q2 bar, and we get output from Q1 and it is connected with DCD hex blue counter. After that J3 is connected with J2 is connected with J1 and K2 is connected with Q1, and we get output from Q2 and it is connected with DCD hex blue, and after that connection we get correct result. After that as our present state was 1 and our next state have to 0 and I get also 0, so that our logic is correct. After that we have to get 4 after 0, so and we get also 4, and at last we are back to the first state, so that our simulation is correct and accurate and our logic is established. Conclusion: it's a countdown circuit. Countdown means that is have two state, one is present and another is next. We use to make our circuit we use K-map for making our circuit and establish our logic. So our sequence was first state start from 7, after that 3, after that 1, after that 0, and after 4 and our result was like this, so that our circuit sequence is working properly so that our implement is successful. Thank you. Assalamu alaikum.